This is Mr. Max. So I'm doing paper 2 of 2021 and I'm doing the following questions 1, questions 3, questions 4 and questions 11. Let's get right to it, starting obviously with question 1. So you can use this obviously to prepare for the examinations. Again, this is also going to be in 3 parts, this particular question paper, and this is part 1 of 3. A polynomial is 2x cubed plus mx squared plus nx plus 5, where m and n are constants. The polynomial leaves a remainder of 45 when it's divided by x plus 2, and leaves another remainder of 21 when it's divided by x minus 2. So that means x plus 2 equals to 0, x equals to negative 2. So once you have a negative 2 into the polynomial, so everywhere I have an x, I replace it with negative 2. That leaves a remainder of 45. So we can go ahead and we can just clean this up. So this is negative 16 over here, plus 4m, because that is positive, minus 2n plus 5 is equal to 45. So just to clean it up, you're going to have 4m minus 2n, and if you get all the numbers on the other side, you're going to have 56, of which I can just go ahead and I can divide this whole equation by 2. So if you were to divide the equation by 2, that is giving us 2m minus n equals 28. Okay. Then the other condition is if it's divided by x minus 2, it leaves a remainder of 21. That means then 2, and you have got 2 cubed plus m times 2 squared plus n times 2 plus 5 leave a remainder of 21. And you can actually go ahead and you can clean this up until you get to say 16 plus 4m plus 2n plus 5 equals 21. And if you get all the numbers to the right side, you are going to end up with 0. And again, if I was to say, okay, I can divide this whole equation here by 2, that will give me 2m plus n equals to 0. So now I have these two equations that I'm going to solve simultaneously. Right, so whenever you are asked to find two unknowns, that is what you will definitely come across. You have to create a system of two equations and solve them simultaneously. All right, so you have got different signs here. So we will solve this obviously by subtraction. So I'm going to use the 2m maybe and eliminate the m's, and if I do that, I'll have negative 1 minus, that's negative 2n equals 28. That implies that n will be negative 14 if you were to divide throughout by 2. And if that is the case, you can actually calculate the value of m by substituting in either one of the equations. So 2m plus negative 14 equals to 0. Of course, that is 2m equals to 14 positive. That implies that m equals to 7. So the solutions therefore n equals to negative 14 and m equals to 7. The question has a B part. They want you to solve this particular equation here, right? So you have a little bit of a trial and error. So you have to find that first factor. So you probably will end up realizing that x minus 1 is a factor. So if I use the remainder theorem and I substitute 1 into this, I say f of 1, you will realize that you should probably end up with a 0. So let's see if we input f of 1, what it gives us. Let's just grab our calculator and make sure we get to the same solution. So we have got 6, and then we have got 1 cubed. No need actually to calculate this because you know that this is just going to be 6 minus 5, again 1 squared, minus 3 times 1, and plus 2, because that gives you 4. If you have got 6, 5, there is a problem here. So let's just quickly go back. We did not put a 5 when we're inserting that, so that gives us naught. Okay, so therefore x minus 1 is a factor. So in order for me to do that, I'm just going to use synthetic division. So I'm going to say 1, and you can use long division if you want to. So I'm going to write the coefficients. 6, negative 5, negative 3, and positive 2. You bring this one down, you multiply, you add, you multiply, you add, you multiply, and obviously if you add, that gives you naught. So 6x squared plus x minus 2, and the other one is x minus 1. So these are also factors. So the important part is just for you to solve the quadratic part, and the quadratic part you can easily solve by factorization. So this is x minus 1. Of course, this gives us 6x squared plus 4x minus 3x minus 2, and eventually it gives me 2x outside, so then I have 3x plus 2 minus 1, you have 3x plus 2. Okay, eventually my factors will be x minus 1, 2x minus 1, 3x plus 2. All right, and now it's effectively very easy for you to be able to identify what because it says solve the equation, so we're just going to let these then equal to 0. So you say x minus 1 equals to 0, 2x minus 1 equal to 0, or 3x plus 2, all of them should equal to 0. And then you can go ahead and you can actually solve the equations. So you will have one answer, x will equal to 1, another answer, x will equal to a half, another answer, x will equal to negative 2 over 3. These are the solutions to that particular equation. Okay, right, so you just have to remember you will have to use the factor theorem and stuff like that. And once you get going, you don't stop. Let's go to question 3 with the same question paper. Question 3 implies that we need to solve this inequality. So I'm going to use the concept where I say that the absolute value of A less than the absolute value of B is going to be used the same as a squared minus b squared. So you're going to say 3x plus 3 all squared less than x plus 5 all squared. At this juncture, I hope you know how to multiply binomials. So this is 9x squared, 3 times 3 is 9, so double of that is going to be 18x plus 9, that is x squared, 5x times 2, that is 10x, 5 times 5 is 25. Okay, right. So I'm just going to go ahead and I bring this on the other side. So 9x squared, take away x squared, plus 18x, take away 10x, plus 9, take away 25, less than 0. Of course, this gives you 8x squared plus 8x minus 16 less than 0. and actually we can divide by 8. That gives you x squared plus x minus 2 is less than 0. Eventually, if you were to sketch this, it's going to be opening up because a is greater than 0. This is this particular value here. And if that is the case, and you are dealing with this, if this is our x-axis, this is less than, so our solutions would be below the x-axis. So we need to find these intercepts here, and we call them the critical values by saying x squared plus x minus 2, let it equal to 0, and we can actually go ahead and factorize that. That will be nothing but x plus 2 times x minus 1. That implies that x will equal to negative 2 or x equals to 1, which are now your critical values, for example. So your answer will therefore be a range below the x-axis, okay, below the x-axis. So x is going to be between 1 and negative 2 respectively. Okay, right, so let's go to question 4. Transforming a relationship to linear form. Let's see quickly when we are looking at our question 4. Just maybe to go back to our previous question. You can also solve this question by using a different method. Maybe you can use graphs. So remember, it was 3x plus 3 is less than x plus 5, the absolute value of that. So we can use using graphs if you were to solve this. The first thing, you have to determine the x coordinates of the points of intersection of the graphs of, let's say, y equals to the absolute value of 3x plus 3 and y equals to the absolute value of x plus 5. Okay, and the way you do that, you probably will be saying, okay, let the absolute value of 3x plus 3 equals to the absolute value of x plus 5, and then you say 3x plus 3 is equal to x plus 5, or 3x plus 3 is equal to negative x plus 5. Simply doesn't matter which one you choose. All right, and you solve for x. That's going to give you two values, so this is nothing but 2x equals to 2, so x here will equal to 1. Or you have to be a bit careful with this one because you are going to distribute that negative. It's going to change everything inside. So it's going to be 4x over there equals eventually negative 8. So x equals to negative 2. Now, what you're going to do after that is you're going to draw the two graphs. Okay, you're going to draw the two graphs. And I actually have done it already for you. This is what you need to see. You see that the green one is the graph of f of x equals to 3x, the absolute value of 3x plus 3, and g of x equals to the absolute value of x plus 5. Now, the solution occurs because you must understand that our scenario was the absolute value of 3x plus 3 is less than x plus 5. So we need to find where is the green graph below the red one. Can you see that? And it's basically from this part here to that part here. So the solutions we therefore have to think of are in this general part. This is the solutions we are looking for, which means values of x between 1 and -2. Okay, that's where this one will be below the other one. Okay, so basically this is what we are looking for. All right, and that is the range, or that is the solutions to that. Okay, that would be if you were to use graphs in order to solve that very same question. Then question 4, a supermarket contains or campaigns to reduce the use of plastic bags. The number of bags N used in a particular week is given by that formula over there, where T is the number of weeks since the campaign began. And here's something that you need to understand with this function. They say sketch the graph. So basically, I'm going to do the following. I'm just going to put in some intervals for myself. So I'm going to say that is 1, perhaps that's 2, that's 3. Let's say we go all the way to 5. Now, if you were to take the function n equals, you have got that 5,000 e minus raised to the minus 0.02 t. If you happen to make t equals to 0, if you happen to make t to equal to 0, then it's going to definitely be at that particular point. If you go back and you so happen to make t equals to 1, for example, then it gives you a different output there. So I'm just going to use my calculator every time for that particular value. So it's just going to go back there again. So first of all, I'm going to bring my 5,000 e raised to the power of 0.02, and I said if you make this a 0, you see that it exactly is at 5,000. So let's just go ahead and open our document again to take us back where we were. Right, so just also save it. Now if I make the value of t to be 1 over here, just go back in there again. Let's say we make that a 1, you will see that it reduces. That was negative over here. Okay, so it comes down. Even if I put 0, it will still be 5,000, so 4,900. So let's suppose 4,900 is, say, somewhere here. So let's go back and put a 2 in there. So you go ahead and put a 2, you see that it drastically decreases. So let's suppose it's 4,800. Let's suppose we put a 3 in there. You'd see that it creates a 4,700. Let's suppose it's somewhere over there. Let's put a 4. 4,600. 4,600. Let's suppose it's there. Let's go ahead and put a 5. 4,500. So you really see that it really gets to the point where the curve, it forms a curve where the curve sort of goes down and down and down. Like that. 2 marks for that. Right. They say calculate the number of full weeks. So let's just write down what we have the n represents the number of weeks, so we have got n equals to 5,000 e raised to the power of negative 0.02t. You say calculate number of full weeks before the number of bags is halved. So if you have to halve, you're going to say 2,500, which is half of that, 5,000 e raised to the power of negative 0.02t. Okay, t is the time, so we need to find t. So again, you can solve this. So first, you're going to divide throughout by 5,000. So eventually, this gives me, if I have to write it myself, it gives me e raised to the negative 0.02t equals to a half. Okay, a half being this over here. So I'm just going to write 0.5, no problem. Okay, right. Now, so when I'm here, obviously, you are going to take the natural log of both sides, leaving me eventually, remember, e, this is log base e of negative 0.02 t. Okay, the e is also over here, log base e. And log base e is the natural log, so the log base e of e cancel. This basically leaves you negative 0.02t here. So I'm not going to write log. If I want to, I can write log base e of 0.5, but that is nothing but the natural log of 0.5. Log base e is the natural log. All right. So whatever that answer is over there, you're simply going to say t would be calculated by saying the natural log of 0.5 divided by negative 0.02. Something else that I need to also maybe perhaps give you a hint is once you have a log of a fraction, the answer will always be negative. Okay, so you can go ahead and play around with it. You can say log 1 over 3. The answer is always going to be negative. Even if you say the natural log of 0.5, the answer will always be negative. In any case, that answer we now have to divide by negative 0.02 in order for us to find our full weeks. So it's 34.65, 34.657, and so on and so on weeks, which you can go ahead and say 34 weeks. Okay. Also, when they were marking this, they were accepting 35 weeks also as an answer. All right. So that takes me then to the last question in this paper. Remember, I said this paper is going to be divided into 3 parts, and the last question here is question 11. So let's go to question 11 of our question paper for part 1. So I'm going to go all the way to question 11. Naturally, I've highlighted it as well. So they say show that equation, the natural log of 3 plus 2 natural log of x minus the natural log of the quantity 2 minus 2x minus 1 is equal to 2 natural log of 2. This is just a constant. You must show that it can be expressed in this quadratic form. So the first part, you can go ahead and say natural log of 3 plus the natural log of x squared by using the power law, okay, minus the natural log of 2x. So that is going to be a 2x minus 1 equals to the natural log of 2 squared. Okay, right. Anyway, when you are adding bases that the log are the same, you just multiply the numbers. So this is 2x minus 1 equals to natural log of 4. If you're subtracting, you are going to divide 3x squared over 2x minus 1 equals to natural log of 4, which you can actually now drop the logs and you will be dealing with 3x squared over 2x minus 1, put it in brackets, is equal to 4 upon 1. Cross multiply in order to clear the denominator, to clear the fraction. That is going to give you 3x squared equals to 4 in brackets 2x minus 1. But of course that is 8x minus 4. And then you just move everything, because quadratic equations, they should always equal to 0. And this was what we're required to show. Okay, 3x squared minus 8x plus 4, as it's appearing there. Now, they say hence solve the equation. So what you need to do is, before you start doing anything, all right, before you start doing anything, you probably have to, very important, use maybe the quadratic equation formula in order for you to find the values of x. All right, so I would say that the discriminant will be negative 8 squared minus 4 times a times c. If I do that part, I get 16. Remember, under the quadratic equation formula, you have to take the square root of that, so I'll have plus minus 4. Right, so one answer for x will be 8. The 8 comes from the quadratic formula, is minus the value of b. Okay, so that will be positive a. 8 plus 4 divided by 2 times the value of a being 3. 2 times 3, that gives you 6. And another answer will be x equals to 8 minus 4, still over 6. Right, so one answer, x equals to, well, 8 plus 4 is 12. 12 divided by 6 is 2. Another answer will be 8 minus 4, x equals to 4 over 6, which simplifies to 2/3. Now that I have that, you will see that everywhere where I have my my natural log there, I'm just going to replace it by this particular question, all right, by these particular answers. So also very important, let me just rewrite the equation down so you don't get confused. So this original equation, the natural log of 3 plus 2 natural log of x minus natural log of 2x minus 1 and equals to 2 natural log of 2. Now you can realize that x obviously is going to be taken up by that space. This 2n plus 1, 2n plus 1 can be written as 2 to the power n times 2 to the power 1. Of course, all of this is not really necessary for you to compare, because in the first instance they said show that can be written as that quadratic. So the only thing that you basically have to do is you say 2 to the power n, let it equal to these answers that you have over here, or 2 to the power n, let it equals to 2 over 3. Now, the first instance is quite easy. If the bases are the same, then n equals to 1. Of course, don't forget to check your solutions. In this particular case, you have to take log both sides, so I'll just simply go ahead and take the natural log. Okay, you can take log base 10. Just so that you can solve, because you can't now write those, you can make the bases the same. So n would be the natural log of 2 over 3. I'm just going to write it out, divided by natural log of 2. Eventually n will give you some value, so let's see what we get. The natural log of 2 over 3, divide that by the natural log of 2. Okay, so you get some negative 0.584. So it's negative 0.5849625 and so on. So eventually, to 3 significant figures, you can say that n equals negative 0.585. So these therefore are the two solutions to that equation. All right. So again, that is part one of the question papers. Stand by for part two and part three.